Here are a couple examples of how we use right triangle trigonometry. And the cool thing about trig is that we don't really have to know very much about a right triangle in order to figure out everything else there is to know about it. So let's find the missing angles and sides of this triangle. Well, the angles are pretty easy. A right triangle has a 90-degree angle, so the other two have to add up to 90 degrees. So this angle is just 90 minus 32, or 58 degrees. And then let's label these other two sides, well, here's the hypotenuse, and then the opposite of 32-degree angle and the adjacent to the 32-degree angle. I'd like to write down these trig functions. The sine of 32 is opposite over hypotenuse, and that's going to be opposite over 18. And so I can just rearrange this by multiplying both sides by 18, and I get the opposite side is 18 times the sine of 32. And if I just go to a calculator, I can get a number for that. It's 9.53 centimeters in this case. Now there's a couple ways I can find this second side. I can use trigonometry, so I'll just write down the cosine function, and I suspect the cosine function because this adjacent side is what's missing. Cosine of 32 is equal to a over 18, and I really solved this in just the same way as I did the last one. So a is 18 times the cosine of 32, and if I get out a calculator, I can see that that's about 15.26 for that side. Now, of course, this is a right triangle, so there's another way to get that side, which is just to use the Pythagorean theorem. And the two methods have to give us the same number, but let's just see if they do. So we have 18 squared, the hypotenuse, has to equal the sum of the squares of the two sides. And if I just rearrange that, 18 squared plus minus 9.53 squared, take the square root. I like to write square roots as just 1/2 power. And that gives us, from a calculator, again, the same answer, 15.27. A little bit different because you have some round-off errors here. Okay. Okay, well, here's another example. In this triangle, we don't know the hypotenuse, but we do know one of the other sides. So again, the other angle is easy to find. It's just 50 degrees. They have to sum to 90 because there's a right angle that already accounts for 90 degrees of our 180 degrees in the angles of a triangle. I'll label the opposite and hypotenuse, and then I'll just start writing some trig functions and see where it takes me. I have the adjacent side, so the cosine of 40 degrees is the adjacent side over the hypotenuse, which is 12 over the hypotenuse. And if I rearrange this, I would really multiply both sides by h and then divide by cosine of 40. I get that the hypotenuse is just 12 divided by the cosine of 40 degrees. When you work this out on your calculator, just make sure that you have your calculator set in degree mode and not radian mode. And so we get a length of 15.66 centimeters for our hypotenuse. Now I need the opposite side, and I could use either the sine function or the tangent function. Let me use the tangent function in this case. So the tangent of 40 degrees is that opposite side over the side that we know, 12 centimeters. And if we rearrange again, we get the opposite side is 12 times the tangent of 40 degrees. Again, make sure your calculator is set in degrees, and we get a number here of 10.06 centimeters. Now, one of the things I can do is just check those sides with the Pythagorean theorem. It has to be true, if I've got these right, that 15.66 squared is equal to the sum of 12 squared and 10.06 squared. And if you work those out, just squaring things on a calculator, you'll see that indeed it comes out just about right. Again, you're always going to have a little bit of round-off error with these kinds of calculations, but that's okay.